Custom Fabricating and Repair, Seal Inspection and Service Video. You will learn how to disassemble, inspect, reassemble, and properly set up the CFR CIP-Able shaft seal. Before we begin, it should be noted that the seal assembly that we're working on today is a one-piece seal assembly in that none of the components are split. So in order to service a seal in this regard, you would have to remove the bearing off the shaft and or any other ancillary components on the shaft. The seal components are available as a split seal. The carbon ring can be purchased as a split ring, as well as the elastomers can be easily split with a utility knife and superglued back together, as well as the O-ring. But in this particular video, we are working with a one-piece seal assembly. The tools you will need to service a seal is a flat file, a screwdriver, a 3/4 inch open end box end wrench, 9/16, ½ inch, a 9/16 socket on a ratchet, a jack bolt arrangement, a 5/32 Allen wrench, a 5/16 Allen wrench, a magnetic base and dial indicator, small flashlight, a Sharpie marker, as well as some paper toweling, and some incidental food contact food grade grease. We've removed the guard from the machine and also made sure that power was disconnected. The CIP header has been removed. We are now going to be removing the 4 bolts that are in the back end of the end plate. They are for the setup tools. We will also be loosening up the set screws, the 5/32 set screws in the drive ring. And then we will be removing the 5/16 cap screws that hold the 2 halves together. The 9/16 bolts are only in the body to close the holes up and are only needed for when we're using the setup tools. The set screws that are in the drive ring are cone point type set screws, and they will make small marks into the shaft, which we'll later deal with. Once all 4 set screws are loose, then we'll be able to take the 5/16 Allen wrench and loosen up the 4 cap screws. As you loosen the cap screws, you can take out 2 of them, 1 on each side for sure. And then the last 2 you'll have to be somewhat careful with removing, because in this particular scenario, the lower drive ring could literally just fall away or fall off the shaft once the cap screws are out. So as we remove the last 2 cap screws, put your hand underneath the bottom drive ring so it just doesn't fall and get damaged. Sometimes they stick together and you will have to use a screwdriver in the little markings that are machined into it in order to be able to spread the 2 halves as you see here. Again, keeping your hand underneath to hold on to the lower half of the drive ring. Sometimes it sticks to the rubber a little bit, but it will come off if you're gentle with it. And then you get the 2 halves off. With the drive rings off, the router sleeve can be drawn back out of the body, and you will see there's a wave spring. We have an O-ring and a groove that rides in the bore, and that's an elastomer that houses the carbon ring. And the carbon ring is fragile, so we want to make sure that we don't damage it or nick it. So we slide the router sleeve back as well as the wave spring. We are going to inspect the bore that the O-ring is in. We call it a CIP bore. What we're looking for here is any kind of galling or scratches. It should be a nice smooth bore that O-ring slides against when it's assembled. So we will clean that up and look in there with a flashlight as much as we can and feel of it with your finger to make sure that there's no damage done on the inside of the bore of that CIP hub. Then the other thing we will take a look at is on the router sleeve itself, the bell end, that curve, this curvature. We want to make sure that there's no galling or rubbing on that edge. And then we're going to check the ceramic face of the router sleeve. It's a very smooth, very durable, very hard surface, and we want to inspect that to make sure that there are no chips, scratches, gouges, dig marks, or any portion of that ceramic face missing. If there's a small chip on a corner, that would be acceptable as long as it doesn't go across the face. If the chip happens to be across the face at all, then the router sleeve is no good. The 2 pins that are on the router sleeve are what keep the router sleeve from rotating and centers over the CIP connection. There's where the O-ring is for the router sleeve, and we're going to remove the O-ring and inspect it for any tears, cuts, abrasion. It hugs in there pretty tight, but with a screwdriver you can work it out of its groove. Take a rag and some solvent and wash it off, inspect it. You can feel of it as you roll your hand around it whether or not there's any cuts or nicks. And should the O-ring be damaged and need replacing, you can cut an O-ring and reattach it on the shaft using super glue. Generally speaking, an O-ring doesn't very often get damaged. It's usually from handling more than anything. But again, we're going to make sure that everything's nice and clean, the O-ring groove nice and clean, clean it out with a rag with some solvent, and as you roll that router sleeve with your hand, you'll be able to feel if there's any other nicks or burrs that need to come off. So, the CIP bore is good, no scratches, no galling. If there was any scratches on the inside of that bore, we'd have to go in there with some emery paper or some kind of a finishing compound to take the scratches out. What we're going to do now is we're going to show and then demonstrate how the router sleeve floats in that bore. Because once the router sleeve is in place, it is only centered by the O-ring itself. There's nothing else that keeps that router sleeve centered on the shaft other than the O-ring. This is the carbon ring that we're looking at right now, and again we're removing it from the rubber holder, and again being very careful and gentle with it. The carbon ring has only goes on one way. The carbon ring has a very shiny, smooth but narrow surface on one side. The back side is wide and dull in finish. That is the back side. When we assemble, we put the shiny side of that carbon up against the router sleeve. That is the sealing surface. You will need to inspect that carbon ring as well to make sure that there are no nicks that cross the face of the carbon ring. If there's a small chip in a corner, that can still prove acceptable as long as there's a flat face yet without the face being chipped out entirely. The carbon ring fits rather loosely inside the rubber elastomer, and that is what's captured with the drive rings. And again, just cleaning off the excess grease. And just a reminder, as it's reassembled, we do not like to get any grease on the faces. This carbon ring can be replaced with a split carbon ring. It's a little more difficult to replace. So we're wiping it down, making sure that the face is good, no chips across the face of the carbon. If the rubber elastomer itself is damaged, that can also be replaced as a split or as a single unit. Now we're just going to clean the shaft up, make sure that we're working with a clean environment all the time. We're going to slide that router sleeve back. We're going to wash now everything with some solvent. We're cleaning the O-ring off to get all the residual grease or any other food debris that might be on there. And then we're going to clean the groove up to make sure everything is good and clean so we can reinstall. You'll notice that we can actually just rotate that router sleeve while you hold a solvent-laden rag in your hand just to wash everything off. The O-ring goes back in the groove. And then we're going to apply some food-grade grease to the face of the O-ring. It doesn't need much, just a small film of grease on the contact face where it will contact the CIP hub. But we will make sure that we've got grease 360 degrees all the way around the router sleeve. And then we will demonstrate how the router sleeve will float in the bore upon final assembly. So again, after it's cleaned up, what we got to do is we're actually going to remove the spring off the shaft, and the wave spring has got ends on it, so we can literally wind it off the shaft, and then later we will wind it back onto the shaft. But with the wave spring off, I can now, by hand, push this router sleeve into the bore and demonstrate how that should float. It's a bit of a push to get it in there, but it will slide in, and you will see that once it's in place that you can actually move the router sleeve back and forth some. There, router sleeve's in, and you could see how that moved in, and you can see that I can actually move it back and forth, and that's how the router sleeve floats in the bore. It all is resting entirely on the O-ring. So now that we can see that the router sleeve is floating properly, we will pull it back out of the bore, and we will put the wave spring back on. And again, it's one of those jobs where you just have to take a little at a time on all sides of the router sleeve in order to draw it back. We're now going to reinstall the wave spring, and it's basically wrapping the wave spring around the shaft, and all you need to do is just keep winding it around the shaft until it's completely wound around the shaft again. Once you have the wave spring back on the shaft, you can check it to make sure that none of the waves are overlapping one another. It will drop into the groove on the router sleeve, and that will actually push up and ride against this lip on the CIP hub, and that's where the pressure comes from in order to apply pressure on the sealing face of the router sleeve to the carbon ring. So in order to do that, we are going to install our preload standoffs and our preload spools. These particular spool pieces are 2 inches long. Some of the older pieces of equipment that we've built have spool pieces that are already welded onto the face, and you would not need these threaded units then, but these are 2 inches long. These are the various pieces that we use in order to set the seals up. Each piece of equipment comes with the 4 2-inch standoffs, 3/8 spools, 5/16 spools, and 1/4-inch spools. And these are the various sizes that are used in order to set up a seal. We primarily work with the 3/8 spool, the one that affords the least amount of pressure, spring pressure. The others are there in the event that you have a different length standoff, and or using the other 5/16 or 1/4-inch if for some reason you would need to apply more pressure to the seal faces. But this is what each and every piece of equipment comes with in order to set them up. So once we have the 2-inch standoffs in place, then we can begin to thread in the 3/8 spool pieces. They're machined to catch the edge, the corner of the router sleeve, and we're going to keep the pins lined up over the neck of the CIP port, and we'll get these all 4 started, and we will hand tighten them to begin with, and then we will get a wrench on it, or in this case a ratchet wrench, and as we tighten we will try to tighten them evenly as we go around, a little here and a little there. What we're actually doing is we're compressing the wave spring, and at the same time that O-ring is being pushed into the bore, so it takes a little bit of force. But all these bolts, if they're tightened evenly, will do a good job of getting the O-ring into its final location. Once the router sleeve is in place, the 4 spool pieces will be tightened down, and we have at that point then have a router sleeve that is properly preloaded into the bore. Again, there are different sizes of these spool pieces, and we are using the longest spool piece, or the 3/8 inch spool piece. There's different sizes for different applications, but for the most part, the 3/8 spool pieces should work just fine. Now we've washed the shaft off again, but now, as you can see, we've got a couple spots on the shaft. The cone point set screws put tiny little divots into the shaft, and we don't want those divots to interfere with the placement of the drive ring. So as we get ready to install the drive ring, we're going to take a flat file, and we want to clean off any material that is around that divot mark. Just want to file that down so it's nice and flat so it doesn't interfere. And also it should be noted that when we install the drive ring, we want to make sure that the set screws aren't going into the same vicinity. You can rotate the drive ring 10, 20, 30 degrees, whatever, just to make sure that when we want to re-tighten those set screws, that they do not land in the same spot as they were previously. But we're cleaning off all the burrs left from the set screws. Comes off very easily with a good flat file, and then you're ready. So now we're going to just wash up and clean the carbon face. We don't want any lubricant on the faces. It's a dry running seal, so we don't want to have any grease in there. We are going to use a little grease in order to aid in the assembly, but we're going to do all we can in order to keep the grease off the 2 faces. So you take the half, and you can see that there's a lip on the back of that rubber, and that small lip rides right in this groove on the drive ring. The drive rings only go on one way, and I should mention that they're also a match set. So if you take more than one seal apart at any given time, you want to keep the 2 halves together because they are a match set. So again, we're going to clean. We want to get everything good and cleaned off before we begin. They're also they're pinned together, so the 2 halves are easy to mate up once they're in place. We're going to put just a real thin film of grease on the area of the drive ring where the rubber mounts, where that rubber elastomer rides. And all we're going to do is just a very thin layer of grease in there, just to give it a little bit of slip and a little bit of slide. Do the same on the other half of the drive ring, just a small light film of grease just on the part where the rubber makes contact. The area where the set screws are, we'll leave that area dry. And again, just a real light film of grease, just something to aid in the assembly. Make sure that the set screws have been backed out sufficiently so that they don't drag on the shaft when you assemble. So you can fit the 1/2 of the drive ring from the underneath side, and you can, if need be, you can rotate it and get it in a position that's comfortable to work with. And then carefully take the other drive ring half and get it over the elastomer properly, and then you can, for the most part, push a lot of it together by hand. There'll probably be about an 1/8 inch gap on both ends, but that kind of gives you an idea that you've got things assembled properly. Then go ahead and start putting the cap screws in. I like to work with the inside screws first, and you get the one on each side started, and without tightening them too much, you can actually spin that router sleeve or the drive ring on the shaft in order to bring up the other bolt, again making it easier and more convenient to get at. You get the two inside cap screws started, then you can get the outside one started. But the other thing is, again, I'm positioning the drive ring so it's easy to get at with the Allen wrench. And then as I tighten it evenly, watching the gaps on the drive ring halves, so I tighten both halves up at the same time. Once I'm comfortable with that, then I will get the outside bolts started, and at the same time as I'm tightening those cap screws, I'm making sure that the routers or the drive ring is tight up against the router sleeve. I want to keep them faces as close as possible so there's no daylight in between. So as I'm tightening them screws, I am applying a forward pressure. Again, checking the gaps to make sure you're tightening it evenly. And once you've done that, then you can go ahead and give them a final tightening. And at this point, we have not tightened up the cone point set screws. That we need to do later. The drive ring is clamped on the shaft tight, and we can take now the preload spool pieces off, and the drive ring should be clamped on the shaft tight enough to hold the router sleeve and the spring loaded pressure on the router sleeve. Okay, now that we've got the preloads off, the drive ring is in position. Even though there's spring pressure on there, the drive ring will stay in its position, but not indefinitely. That's what the additional set screws are for. So there's pressure. Now what we want to do is we want to make sure that the drive ring runs true to the router sleeve, or we're going to check the run out of the router sleeve. As we go into the next part of our setup, we are going to mount a magnetic base dial indicator on a bearing, and then mount the dial indicator probe on the corner of the router sleeve to be able to measure the router sleeve runout. However, before I begin this next session, I want to stress that when we are checking the router sleeve for runout, the shaft is rotating. This can be done either by manually rotating the shaft, which they can be heavy and take some energy to rotate. You could also take a fan cover off and spin the drive by hand. For example, if you have a motor on a gearbox, you can usually take the fan guard off and spin the fan by hand. Or in this particular case, since we have a variable frequency drive set up on the motor, we have turned the drive down to a very low frequency so we can turn the shaft very slowly. This is done under power, but I wish to stress again the necessity for safety and precaution if you are going to do any of this while it is under power. So you need to make sure that you have ample assistance if you're going to do this under power, and that you have safeguards in place so that there are no personal injuries. The shaft is now rotating, and you can see that we have the dial indicator up against the corner of the router sleeve, and we are actually looking at the float of the router sleeve. As the shaft is turning, you can see the dial is moving. It is moving approximately 3 to 4 thousandths of an inch at this particular point. We like to have it within 5/1000 of an inch, so even now the router sleeve is set up within specification, but for demonstration purposes we are going to adjust it. What we're going to do with the Sharpies, we're going to mark the high spot about where it starts and stops so we can see the area where the dial indicator goes high, or where the router sleeve is actually, or the drive ring is coming away from the blender. So again, as this router sleeve comes around, we are going to see the high and the low on the drive ring, which is right there. So we're going to stop that as a convenient location, and then we will install the jack bolt, and we'll probably, which we like to do, is stop the shaft so the high spot is directly underneath the dial indicator. So now we're going to put our jack bolt in, and we're actually going to push the ring in to bring that needle back to 0. The jack bolt is just a long threaded nut with a bolt screwed in each end. One end has a jam nut, so we can put that between the race of the bearing and the face of the drive ring, and when I expand the bolt out, it will drive or force the drive ring forward, and that should zero out our dial indicator. You may have to do this several times in order to get it so the runout is within 5/1000 of an inch. So now that I've got the jack bolt hand tight in its location, I will put a wrench on it and a second wrench so I can turn the bolt out, and what will happen is it actually forces the drive ring in, which then forces the router sleeve in as well. So instead of the 15-20 thousandths runout, which is normally what we would see, this one happened to set up rather easily. So we've moved the drive ring. We're going to reposition the dial, and then we will rotate the shaft to verify the adjustment and if it was adequate. So again, we're running this at a very, very slow speed, and we only need to turn it a couple of revolutions just to verify if the adjustment we've made, if it's been sufficient. And as you watch this, you can see that the router sleeve runout now is within about 1/1000 of an inch, maybe 1.5 thousandths. So, and that's very, very acceptable, very well within our tolerance of 5/1000 of an inch. So now that we've got the drive ring and the router sleeve running true, we can stop the shaft. We can take our dial indicator off. We can go in and tighten up the 5/32 cone point set screws, which will bite back into the shaft. Once we've got them tight, then we can use our 3/4 inch wrench and remove the 2-inch standoffs. Once all the standoffs are out, we can put the short bolts back in the holes, use a little anti-seize if necessary, and the job is complete. Thank you for watching.